So I do think it's possible that at the moment there's one civilization in the Milky Way. Holy wow! This is amazing. We are going to be learning so much in the coming decade. Located 7 trillion miles away from Earth is an unprecedented discovery made by the James Webb Telescope. City lights in space. This remarkable finding has ignited a strong wave of curiosity about the possibility of extraterrestrial life. The telescope focused on Proxima Centauri b, the closest exoplanet to Earth, showing unusual bright lights emanating from it. What could be responsible for these city lights on Proxima Centauri b? Could this signify the presence of life beyond our planet? Come with us as we delve into how the James Webb Telescope detected these extraordinary objects in space. For years now, scientists and humans in general have carried out research to get a glimpse of life beyond our solar system. Any evidence perceived to back up this fantasy about space has been gladly welcomed over time. Recently, the scientific community got the shock of their lives when solid evidence of life forms existing in space was observed by the James Webb Space Telescope while scouting outer space and relaying vital information back to Earth. The James Webb Space Telescope noticed strange city lights shining from the exoplanet Proxima Centauri b. Just as its name implied, the city lights looked like they lit up a distant city. The possibility of an alien city existing on the star has left scientists reeling in amazement. Every one of them is baffled because it seems like this is the existence they've all been waiting for. If this turns out to be true, as everyone thinks it is, it means that there are intelligent life forms organizing civilizations foreign to what humans know in outer space, and we are only just discovering it. Peering into the city lights that are located 7 trillion miles from Earth, NASA engineers can't help but wonder how long these lights have shone in space, waiting for humans to grow the required technology to detect them. David Kipping, an astronomer from Columbia University, describes the Proxima b exoplanet, where the city lights were found, as tricky. He said so because this star system nearest to us has varied heating patterns that aren't similar to other planets. The usual rocky planets are known to take in sunlight and emit infrared radiation. However, it's not so for this exoplanet, as its infrared nature is quite different from that of its host star, Proxima Centauri. This makes for a good observation by the James Webb Space Telescope, JWST, which came in handy as the right tool for the job. The JWST is able to easily detect infrared wavelengths. The characteristic heat signature of Proxima b will play a huge role in discovering the universal secrets of its atmosphere. This will be as a result of the latest technology of infrared imaging capabilities possessed by the JWST. Scientists plan on utilizing the telescope to reveal the mystery surrounding this planet's atmospheric conditions. They also aim to use the Webb telescope to check the possibilities of residing on this exoplanet. The James Webb Telescope has the infrared sensitivity that's required to explore what happens at Proxima b's nighttime. Picking up the faintest rays of light in the cosmic darkness is usually a struggle for space telescopes, but not for the JWST, as it can pick out even the tiniest rays of light from space. It's the perfect instrument to verify if the rumors of city lights on Proxima's night side are true or false. Every artificial illumination in the cosmos can be sensed by the telescope as long as it falls within a frequency band that's 1,000 times narrower than starlight. How does Proxima Centauri b compare to planet Earth? Proxima b has an interesting relationship between its stellar features and surface interactions. The day side of the exoplanet contains many solar panels that harness the bubbling radiant energy possessed by the star. Its spectral edge also reflects in light rays. At the same time, when Proxima b completes its orbit around its host star, Proxima Centauri, it experiences day and night periods just like what we have on Earth, with the daytime getting high on solar heat and the evening experiencing coolness. The planet is known to have temperature fluctuations that are determined by its composition. For example, if there's no atmosphere on Proxima b, the difference between its day and night periods will be wide and far between. If there's no moderating influence of atmospheric gases and oceans, the temperature of the day side will be so hot, like a black body, and the night side will horribly drop into cold darkness. The degree of temperature variation is a good subject for astronomers to unravel a deeper understanding of Proxima's atmospheric composition. Having unrivaled infrared imaging capability, the JWST can efficiently examine the planet's thermal emissions to provide insightful data about its atmospheric properties. Interestingly, The orbit of the JWST around the Earth falls in alignment with Proxima B's orbital period, making complete observations of its day and night periods within 11 Earth days. Since it indeed has an atmosphere, the next step will be to assess its atmospheric chemistry to determine if it can accommodate life. Some good pointers in determining if there's life are the presence of gases like oxygen, water vapor, and methane. If these elements can be found on the planet, it means that it supports habitable conditions. The process of successfully determining this requires scientists to be meticulous enough as they capture and examine light rays that move through the planet's atmosphere. This is an incredibly challenging task to undertake. Even if the JWST possesses great capabilities for characterizing planetary atmospheres, it has a different major objective. The telescope has been designed to only analyze the variations in water vapor, carbon dioxide, and methane concentration when it comes to identifying bonded oxygen, which is a vital indicator of life. The JWST is limited in this area, but it still has valid reasons to search for other elements on the planet. One of such reasons is ozone, which gives away an accurate level of vitality in the atmosphere. It's also worth noting that the James Webb Space Telescope doesn't have absolute capabilities and can only peer at a few of the closest habitable worlds to Earth. Carrying out a thorough atmospheric investigation, astronomers are now tilting toward ground-based observatories like the Extremely Large Telescope, ELT. The ELT is a telescope that has been scheduled to start operating in 2028 and is carefully positioned to gaze deeper into the atmospheric structure of faraway exoplanets. It will produce data on these planets that will offer comprehensive and vivid insight into their level of habitability. NASA scientists and everyone are happily waiting for the deployment of future space telescopes like these. Until then, however, the James Webb Space Telescope will continue to be a vital tool in our quest to uncover the mysteries of distant exoplanets. Even with its current limitations, the James Webb Telescope has the potential to offer deep insight that will revolutionize our understanding of exoplanetary exploration now and in the future. Scientists have an objective for future space telescopes: to reduce the amount of bright light coming from a planet's host star so that astronomers can clearly see the lights reflected from a planet itself. They plan to do this by using internal masks or gigantic external satellites shaped like umbrellas, similar to using your hand to block out rays of the sun to enable you to see an object clearer. In the bid to reduce the fierce brightness coming from the host star, future telescopes will be better positioned to study faint reflections of light coming from a distant exoplanet, allowing for a clear analysis of its atmosphere and likelihood of supporting life. Doing this comes with its own challenges. However, scientists will have to differentiate between gases generated from life and those generated from geological processes such as volcanic activity. Astronomers aren't relenting in their bid to understand the characteristics of exoplanets, so they are more able to discover signs of life and distinguish them from false positives. The Webb telescope contains a preview of scientific advancements from the research of exoplanets, offering a sneak peek into the amazing discoveries we're yet to find. As we stretch our understanding and exploration of the cosmos farther and farther, we are better positioned to understand the workings of the universe and our various roles in it. After looking through all the planets in space, scientists have yet to find any that host life. Despite decades of searching through space for signs of life, the quest for forms of life on other planets continues. Are we alone in the universe? For millions of years, throughout human civilizations, humans have always wondered whether they are the only ones living in the universe. This is a very old longing that still hasn't left us in this present time. Even today, scientists have the James Webb Telescope in outer space trying to spot alien civilizations hidden amongst us while studying all kinds of planetary bodies for signs of life. At the same time, the narrative that some aliens are truly out there in the stars, just waiting for humans to find them, is indeed a popular narrative. To provide an answer to this question, two American astronomers, Jill Tarter and Thomas Pearson, started a project called the Search for Extraterrestrial Intelligence in 1984, known as the SETI Institute. This is a non-profit venture that plans to sift through cosmic signals to pick up only radio signals from space. Radio signals have the ability to travel long distances without getting scattered or absorbed like other types of radiation, hence their decision to focus on them. Due to this characteristic feature, Radio signals are more likely to be detected by the 42 radio telescopes that constitute the Stellar Allen Telescope Array found in the Cascade Mountains of California. Though the SETI Institute has religiously observed signs of these radio signals generated by alien life, there haven't been any such signals for over 30 years. Jill Tarter is enthusiastic that they'll have a positive result, as they want to use the tools of the 21st century to accelerate the search. In the words of Jill, "I wish that you would empower Earthlings everywhere to become active participants in the ultimate search for cosmic company." Are there any other ways to identify alien life in outer space besides picking up radio signals? There have been some recently proposed ideas that life forms on other planets can be detected by their use of artificial lighting, just as we have in our cities on Earth. Astronomers Avi Loeb and Edwin Turner made this suggestion. However, the practicality of the theory has been met with a lot of challenges. This means that space telescopes will have to zoom into individual stars within the universe to know if any of them contain an alien civilization. Scientists believe that alien civilizations most likely use artificial lighting to extend the daylight hours so they can stay productive for longer, just as we have on Earth. Hence, they think that a space telescope sensitive to these artificial lights will be able to easily spot such alien cities. They also argue that advanced aliens living on exoplanets far away from their host stars would need to use giant mirrors to collect light and direct it to their homes. If a telescope can be built to detect artificial light produced by an advanced civilization, it could offer scientists another intriguing method to locate intelligent extraterrestrial life. The NASA engineers think that the James Webb Telescope is able to detect artificial lights. However, it's worth mentioning that this telescope can only do that if the light falls within 1,000 times narrower frequency band compared to starlight. It's a hopeful notion that future telescopes can be optimized to detect such signals better. Imagine a future where telescopes are advanced enough to detect artificial light from planets. It's a promising thought as we continue to explore the cosmos. New advancements in technology promise to enhance our understanding of distant worlds. The next generation of space telescopes is poised to revolutionize our search for life. These instruments are being designed to improve resolution and sensitivity, enabling scientists to examine the atmospheres of exoplanets in unprecedented detail. One exciting area of research involves the study of biosignatures, chemical indicators that suggest the presence of life. Scientists believe that certain combinations of gases, such as oxygen and methane, could point to biological processes. The potential discovery of these signatures could fundamentally change our understanding of life's distribution in the universe. Moreover, the study of extremophiles, organisms that thrive in harsh environments on Earth, has broadened the scope of what constitutes habitable conditions. Life has been found in the depths of oceans, beneath glaciers, and in acidic hot springs, suggesting that life might exist in unexpected places on other planets or moons. For instance, the icy crusts of Europa, one of Jupiter's moons, and the subsurface ocean of Enceladus, a moon of Saturn, are prime candidates for astrobiological exploration. Additionally, missions planned for Mars aim to analyze soil samples for organic compounds. Rovers equipped with advanced laboratories will search for evidence of past life, which could provide insights into the planet's history and potential for current microbial life. Public interest in extraterrestrial life continues to grow, fostering a collaborative environment between scientists and the public. Initiatives that engage citizen scientists in data collection and analysis can accelerate discoveries as large datasets become increasingly accessible. Ultimately, the quest for extraterrestrial intelligence is not just a scientific endeavor but a philosophical one as well. It challenges humanity to contemplate its place in the universe, prompting profound questions about existence and connection. As we push the boundaries of exploration, we inch closer to understanding whether we are indeed alone or part of a vast, interconnected cosmos.